Section 5.1, midsegment of a triangle. The next two slides will be review slides. Here they want us to find the coordinates of the midpoints of a segment. So we're given point A on a coordinate plane and point B on a coordinate plane. We want to determine the midpoint of segment AB. Recall the formula for finding midpoint is x sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2. All we need to do is determine and label which ordered pair we want to let be 1 and 2. This is your choice. I'm going to let this be x sub 1, therefore this is y sub 1. Therefore this ordered pair for point B is going to be x sub 2 and y sub 2. Now all I need to do is substitute into my formula. My x midpoint is going to be the first section for the x coordinate, which is x sub 1, which I am going to substitute in negative 2, plus x sub 2, which is 4, divided by 2. Therefore, when I simplify, that's 2 divided by 2, and I get 1. The y midpoint coordinate is determined by the y sub 1, y sub 2 divided by 2. When I substitute, I'm going to get 3 for y sub 1. For y sub 2, I'm going to substitute in 1, divide by 2, and I'm going to get a value of 2. Therefore, here, I'm going to get a midpoint ordered pair for segment AB to be 1, 2. On the next slide, we're going to review the concept of determining slope given a set of ordered pairs. So we want to find the slope of segment AB with the endpoints given to be a negative 2, 3, and 3, 1. Again, I need to label the ordered pairs x sub 1, y sub 1, x sub 2, y sub 2, and substitute those values into the formula. So recall, I'm given slope, which we know is m, to be y sub 2 minus y sub 1. When I substitute, 1 minus y sub 1 is 3, over x sub 2 is 3, minus x sub 1, which is a negative 2. And when I simplify, I'm going to get 1 minus 3, which is a negative 2, over 3 minus a negative 2, which is 3 plus 2, which is 5. Therefore, I have a slope that is a negative 2/5. Our first theorem is the triangle midsegment theorem. If a segment joins the midpoints of two sides of a triangle, and here this is what I have illustrated in my diagram. I have a triangle. We can label that triangle A, B, C. And they also identified the segment to the interior of the triangle that intersects two of the sides. And I know the endpoints of that segment, we can call them D and E, must be midpoints of segment AC and AB. I know that because on segment AC, I'm given that AD and DC are congruent. Therefore, D must be the midpoint. And on segment AB, E must be the midpoint because I'm given that AE and EB are congruent because of the double tick marks. Therefore, this first part of the theorem does work out, that if a segment joins the midpoints of two sides of the triangle, which is segment DE, then that segment is parallel to the third side. Well, it intersects these two sides, and it's stating that segment DE is parallel to the third side, which is CB. And also, it is half its length. That would tell me that if this is x, this is 1/2 x. Or in other words, if this would be 8 inches long, then DE would be 4 inches long. Here's a proof represented in the coordinate plane. I'm given the vertices of a triangle to be 0, 0, 6, 8, and 8, 0. Here I determine the midpoints of the first segment of 0, 0, and 6, 8. Here's the midpoint. When I substitute into the formula, I get 0.34, which is demonstrated here in the blue vertice. And the segment side of the triangle, I find its midpoint and determine that ordered pair to be 7, 4. So therefore, I have a segment that intersects the two sides of a triangle. Now, I want to determine, are these two segments parallel? Here, I determine the slope of each. I find the slope of the first segment, which is here, 4 minus 4, and 3 minus 7, which is the segment joining the midpoints of the triangle to be 0, and I find the slope of the third side of the triangle and also determine it is 0. Therefore, these two segments are parallel, the midsegment of the triangle and the third side. Now I need to determine, are they half as long? Let's take a look at the size or length of the third side. It is 1, 2, 3, 4, 5, 6, 7, 8 units long. Therefore, the midsegment must be half that length. Let's count. 1, 2, 3, 4. 4 units. Therefore, this is just a coordinate proof that verifies the midsegment theorem. Here's our first example. In triangle ABC, points D, E, and F are midpoints. Find the length of AC, DF, and CB. Also determine which segments are parallel. If I take a look at the entire triangle, ACB, I know that D and E are midpoints of AC and AB. Since they are midpoints, I know that I can put tick marks in for these two sides. I can put double tick marks for AE and EB. If that's the case, then I do know that this segment is parallel to the third side. I also know that if this is 7, this has to be double that length. Therefore, segment CB must be 14 units long. And that's what we needed to determine. One of the segments, CB, is 14 units long. I also can break that down into saying that CF is 7 and FB is 7, because it's also given in the directions that point F is a midpoint. Therefore, I know I can put triple tick marks for these segments. Now, I can take a look at segment DF and realize that that's the midsegment of these two sides of the triangle. Therefore, DF is parallel to the third side. And I'm given that this segment, AE, is 10. Therefore, EB must be 10. And the entire length of segment AB must be these two segments added together, which is 20. And I know that DF is the midsegment of the triangle and must be parallel to the third side and half as long as the third side. So DF is 10, another segment we needed to determine. And we're also given EF. EF is a midsegment of the triangle also, and I know that it's parallel to the third side, and it's half as long as the third side. If this side is 12, this must be double that length. Therefore, this must be 24 units long for segment AC, which is another side we needed to determine. Segment AC is 24 units long. Also, since D is a midpoint, that makes each segment here AD and DC 12 units. On this example, I'm asked to find the value of x. I'm given a triangle, and I'm given that this is a midsegment of the triangle. I know that because I have double tick marks on the left side, which makes this the midpoint, and single tick marks on the right side, which makes that the midpoint. Therefore, that is the midsegment of the triangle, and if that is true, then that side is parallel to the third side, and this is half as long as that. Therefore, I can set up an equation to solve for x. I know that if I have 2x minus 6 equals, and this segment is half as long as that. Therefore, what I can do is just double that segment and set that equal to 88. Then all I need to do is solve for the value of x by solving this equation. That gives me 2x, add 6 to both sides. That's going to give me a value of 94. then just divide by 2. And when I divide by 2, I get x to be 47. I also could have solved this problem by just taking half of that expression. In other words, I could have set this up by going 1/2 of 2x minus 6 equals 44. That would give me, when I distribute, x minus 3 equals 44. Add 3 to both sides, I get x equal to 47. I find this to be the easiest way, but both procedures will work. On my next example, they want us to find the value of each segment. Point D, E, and F are midpoints. Therefore, I know it wasn't asked, but let's take a look at which segments are parallel. If D and F are midpoints, that is a midsegment. Therefore, I know that DF is parallel to the third side, which is BC. I know that DE is a midsegment. Therefore, that tells me that DE is parallel to the third side, which makes that AC. And my third midsegment is FE, and that's parallel to its third side, which would be AB. But what they wanted to do is determine the value of each segment inside this problem. Well, let's start at the base. I know E is a midpoint. Therefore, if BE is 3, that makes EC 3. I also know that BC must equal 6. And I know that DF is half of BC. Therefore, that is 3. Or in other words, each one of these segments must equal 3. I'm given that AC is 18. F is a midpoint. Therefore, AF is 9. And FC is 9. And I know that DE is half AC. Therefore, it is also 9. I'm given that FE is 5. Therefore, I know that this is half of AB. Therefore, AB must be equal to 10 units. And that AD is 5 units, and DB is 5 units. On these two examples, they want us to find the value of x. Here, I'm given a triangle. I'm given a segment that is a midsegment. Therefore, I know that these two segments are parallel. I also know that this segment is half as long as that segment. Therefore, I can set up an equation. 5x minus 12 is equal to half the length of this segment, which is 5. Then just solve the equation. I get 5x, add 12 to both sides, I get 17. X, when I divide by 5, is 17/5. In the next diagram, I'm given a triangle that has a midsegment. I know that because the midpoints are here because of the single ticks, and the midpoint here because of the double ticks. Therefore, I know that this midsegment is parallel to the third side and also half as long. But here, what they want me to do is determine angle measure. I know that if two parallel lines are cut by a transversal, then I have same side interior angles that must be supplementary. Therefore, all I have to do is take 118 from 180. And that will give me x to have an angle measure of 62 degrees. Another way to do that is to find the linear pair here. I know that these two angles are a linear pair. That means they're supplementary. I can subtract that from 180 again, and I still get 62 degrees. And I can use another theorem with parallelism. If two parallel lines are cut by a transversal, then corresponding angles are congruent. Either case, I get the value of x to equal 62 degrees.